Howdy, this lesson is going to walk you through how to do 1 and 2 step equations. So if you're in my class and you are watching this and you need me to go a little bit slower than I'm going to go on this video for YouTube, you can go back into our Canvas class and look at our lesson for either September 1st or September 2nd, depending on what day I have you. And I go a little bit slower in class, okay? So the first thing I want to do to review solving equations is talk about what you learned in elementary, middle school, and then now high school. So in elementary, you might have seen a problem like a square plus 2 equals 5, and you had to figure out what went in that square. And most of you would probably say, well, 3 went in that square. And then I would say, well, how do you know a 3 went in that square? And you would say, well, that's the only thing that makes that problem true. So before you even realized you were doing it, you were solving for a variable. You knew what that square represented. You knew that 3 had to go in that square to make the left side of the equation and the right side of the equation equal to each other. And then in middle school, you were introduced to variables. So instead of squares or just filling in the blank, right, you were introduced to a variable, an unknown value. And a variable is usually represented by a letter. It could be X, it could be Y, T, Z, does not matter what it is. And it works the same way. You're trying to find the value of that variable, the value here of X, that would make the equation true. Well, it's the same as the elementary one. The only number that will work in place of X is a 3. And then in 8th grade and then in high school, you are going to get equations where they look a lot more complicated. So you can't just do it in your head. So if you can't just do the math in your head, how do you solve for X? So that's what we're going to review today. So the first thing is you can manipulate equations in math, but you have to be consistent and fair. So what I mean by that is if you do something to one side of the equation, let's say you change something on the left side, you have to be fair and you have to also do that exact same thing to the right side. That's called balancing an equation. So you can change things up in math with equations, but you have to do it to both sides. If you don't do it to both sides, you don't have a balanced equation and you basically just wrote a brand new equation. So you have to be fair and do it to both sides, okay? The other thing that you need to know to solve for variables and solving for equations is you need to know what an inverse is. So an inverse means opposite, so inverse, opposite. And you need to know the inverse operations from one another. So operations in math are addition, subtraction, multiplication, and division. And you need to know which ones are opposite. So the inverse of addition, the opposite of addition, is subtraction. The inverse or opposite of subtraction is addition. The inverse or opposite of multiplication is division. And the inverse of division is multiplication. Okay, so make sure you know which operations are opposite or inverses of each other. Okay, so let's actually get into some problems and I'll explain it as we go. Okay, so on number 1, I can see that I don't have my variable by itself. I want to know what X is, which means I have to isolate the X. I have to get it by itself. So that means everything that is on the same side as the X has to go away. Okay, so in order to get the X by itself, I have to get rid of everything else on the same side of it. So I see that it has a minus 10 because it's X minus 10. So that's the same thing as a negative 10, okay? So we just talked about knowing the inverses. So we need to do the opposite of what we see here. So this is a minus 10. And in math, the way you're going to get rid of minus is by doing its inverse, which is adding, okay? So you're adding 10. But if you're adding 10 to one side of the equation, you have to add it to the other. Okay, we didn't touch the x, so you can just bring it down. Your 10s cancel, and 22 plus 10 is 32. Now that the x is isolated, it's by itself, you know the value of x, which is 32. So you can box your answer. Okay, so let's look at number 2. So number 2 is 3x equals negative 15. I know that I'm trying to solve for the variable, which is x, but it's not by itself, and it looks a little different than number 1. I know that the 3 and the x are being multiplied together because they're right next to each other. The 3 is the coefficient, that means the number out in front of x. I know they're being multiplied together, and so how do I get rid of multiplication? I do the opposite. So the opposite of multiplication is division. Okay, and the reason I know I'm trying to get rid of the 3 is because that is what is on the same side as x, right? If I need the x to be by itself, I need it to be isolated. That means the 3 has to go away. And the way we get rid of it is by doing the opposite math that's done in the problem. So 3 and x are multiplied. They're right together. There's no sign in between. That means multiplication. So to get rid of the 3, we're going to do the opposite, the inverse, which is divide. But if we do something on one side of the equal sign, we have to do it on the other. We have to keep our equation balanced. Okay, 3 over 3, that cancels out. You would just get 1. So you would have 1x, but we know 1x is just the same as x. And then negative 15 over 3 is a negative 5. So now we know the value of x is negative 5. I am going to show you a little trick here for multiplication and division. If you have trouble when it comes to positive and negatives, remembering which is which, you can draw, we always called it the kissy face. So it's like 2 closed eyes and then a plus sign mouth, okay? And what you can do is, if you're trying to figure out what the sign of your answer is going to be, you can look at the 2 numbers that you're dividing, or this also works for multiplying. So I see that the 15 up here is a negative. So I'm going to cross out one of my negatives down here in my face. Remember, this is just a little trick. If you don't need it, that's fine. And the 3 is a positive. Okay, so this 3, there's no sign in front, so we know it's positive. So I'm going to cross out the positive. The sign that's left right here, that is the sign of your answer. So our answer is going to be a negative. So that helps with multiplication and division. It does not help with addition and subtraction. And I'll do that again. We have a problem that I'll do that again so you can see. Okay, so let's look at our third problem. So I had x over 2 equals 11. So anytime you have a fraction is a division problem. So to get rid of division, I do the inverse of division, which is multiplication. So I see that it's being divided by a 2, which means I need to multiply it. I need to multiply it by a 2. Okay. But if we do something to one side, we have to do it to the other. Okay. Our 2's cancel out. And actually, if you wanted to make this to a fraction, you could. Okay. So our 2's cancel out, and we would be left with x over 1, which is just x. And 11 times 2 is 22. Okay, so that was a division one. So we had to get rid of it being divided by a -2 by multiplying by a -2. So remember, I said if this is a little too fast, I take it a lot slower in our lesson from class that you can find in your Canvas page, okay? All right, let's look at number 4. So number 4, the x is on the right-hand side this time. It doesn't matter. It does not matter which side the x is on, because when you solve at the end, if you get x equals 5 or 5 equals x, those are the same thing. It's just the order that's different. Okay, so don't worry about which side the variable is on. All you want to worry about is getting the variable by itself. So I can see that the variable is being multiplied by a -6. I know this because they're right next to each other. That means the -6 has to go away. Okay, so I'm going to divide by, and I purposely made a mistake because I want to point something out. Okay, I have a lot of students that say, oh, okay, it's a -6, so I'll divide by a +6, okay? Because they're thinking inverse, they're thinking opposite. But it's not the opposite sign that we're worried about. It's the opposite operation. So they're being multiplied right here. So to get rid of it, you divide. If you want to get rid of a -6, that means you have to divide by a -6. So be really careful with that. That's a very common mistake I've seen in the past. You have to divide by the number you're trying to get rid of, okay? If you have a -6, you have to divide by a -6, okay? All right, so we have -60 divided by -6. I'm going to show you my trick again. I'm going to draw my face. Okay. So the 60 up here, that's a negative. So I'm going to cross out one of the negatives. Okay. I see that the 6 is also a negative. So I'm going to cross out the other negative. And that means my answer must be positive. Okay, so I know it's going to be positive, and 60 divided by 6 is 10. Okay, if you don't need that trick, like I said, great. If you need it, it's there to help you, okay? -6 and -6 cancel. They make 1. And we know that 1x is really just x. Okay? All right, let's look at another one. All right, so number 5, it says 5d plus 2 equals 52. So the only thing that makes this problem a little bit different is that now instead of just having one number we need to get rid of, I see a 5 that I need to get rid of, and I see a 2 that I need to get rid of. Okay, so how do I know which one to do first, or does it matter? It actually does matter. And I want you to think of the 5 and the D as a pair. They go everywhere together until the very end. So they're connected, right? They're being multiplied. There's no sign in between. They're right next to each other. And they are going to stay right next to each other until the very end, which means that 5 is the last number we're going to try to get rid of. Okay? So that means we need to get rid of that plus 2 first. So the inverse or the opposite of a plus 2 is a -2. If I do something to one side of the equation, I have to do it to the other. I can bring down the 5d. My 2's cancel. And 52 minus 2 is 50. Okay, so now I'm not done. This is a two-step problem. I see a 5D. So 5D, they're right next to each other. I know they're being multiplied. So to get rid of the 5, I do the opposite of multiplying, which is dividing. Remember, it's not the opposite sign, so I'm not dividing by a -5. I'm dividing by the number I'm getting rid of. So I'm dividing by a 5. But if I do it to one side, I have to do it to the other. Okay, 5 over 5 is 1. Okay, and we know 1D is the same as just D. And 50 divided by 5 is 10. Okay, let's look at number 6. 8 minus 2p equals 68. So I need to get rid of an 8, and it looks like there is this -2 or a -2 that I also need to get rid of. The -2 is touching the p. They're connected. They're being multiplied. So I'm going to get rid of that last. They're going to stay together as long as they can. So I'm going to get rid of this 8. But I don't see a sign out in front of the 8. It doesn't have a plus or a minus or anything out in front of it. So how do I know what to do? Well, if I had 8 candy bars and I needed to get rid of them, wouldn't I subtract them from my supply? So a +8, to get rid of it, you would subtract 8. But if we do something to one side, we have to do it to the other. Okay, your 8's cancel, and you're left with -2p, and 68 minus 8 is 60. Okay, -2 and p are being multiplied. They're right next to each other. They're connected. So the opposite of multiplication is division. So to get rid of that -2, I'm going to have to divide by -2. If I don't divide by -2, and I don't want to confuse you, divide by -2 because that's the number I'm trying to get rid of. Okay. -2 over -2, that'd just be 1. So 1p is the same as just p. And then I'll do my trick one more time. Okay, 60 is a positive, so I'm going to cross out the plus. 2 is a negative, so I'm going to cross out one of the minus. So what's left is a minus, so I know, I know my answer is going to be negative. And 60 divided by 2 is 30. Okay, we have 4 more. I know it's a lot. All right, so number 7 says 1/7 t plus 5 equals -10. 1/7 t plus 5 equals -10. So this has a fraction that's a little different, but it doesn't change what we do. That fraction is attached to the t. They're being multiplied, so we get rid of that last. So let's get rid of that plus 5 first. The inverse or opposite of a plus 5 is -5. Okay. So I brought down my 1/7 t, my 5's canceled, and -10 minus 5 is -15. Be really careful that you're doing that correctly. Okay, so I see a 1/7. It's being multiplied. Okay. T is being multiplied by 1/7. But I'm actually okay with the T in the 1. It's really just like the denominator of a 7 that I don't like. Okay. So to get rid of this 7 down here, because 1 and 7 are being divided together, I can multiply by the reciprocal. That means flipping the numerator and the denominator. Okay. And then if I do that to one side, I have to do it to the other. Okay. So my 7s would cancel out here. My 1s would cancel out there. And I'm just left with T. Okay. -15, if you want to make that into a fraction, you can. And -15 times 7 is -105 over 1. Which is the same as just -105. Okay, so I'm going to explain one more time what I did up here. So I knew that 1/7 and T were being multiplied together. 7, the denominator, was the real problem. But what I did to get rid of the whole fraction is I multiplied by the reciprocal. The reciprocal is when you flip the numerator and the denominator. Okay, and the reason I did that is because then your 7s cancel and your 1s cancel. Okay. All right. Just a few more. I know this is a little long. All right. 0.2n plus 6 equals 11.8. The 0.2 and the n are connected, so I get rid of that last, and I see a plus 6. To get rid of a plus 6, I subtract. But if I do it to one side, I have to do it to the other. I bring down my 0.2. My 6's cancel. And 11.8 minus 6 is 5.8. Okay. So now my n is being multiplied by 0.2. I don't want that. I need n to be by itself. So to get rid of the 0.2, because it's being multiplied, I need to divide. Okay. These cancel out and I just get n. And 5.8 divided by 0.2 is 29. Okay. All right, let's look at our last two. So our last two, what makes these different is that the variable is actually inside of a fraction. So how do we undo this? Okay, so the first thing that we're going to do is we are going to try to get rid of that denominator. Okay, so this is a little bit different because the variable is inside of it. You don't want to get rid of this -3 first, okay, because you want the problem to automatically be more simple. I'm trying to make that easy to understand. You want the problem to be simple, and so you need to get rid of this denominator first. Okay, so this h minus 3, it's almost like a pair. It's almost like you could write it like it was in parentheses. So you don't want to separate that yet, okay? So when something is being divided by a 4, we want to get rid of that 4. We're trying to get h by itself. So to undo division, we're going to use multiplication. So this whole side is going to be divided by 4. Okay, but if we do something to the left side of the equation, we have to do it to the right. That means we also have to multiply the right side by 4. Okay, and I know now the left side looks a little crazy, but the best part is the 4s actually cancel each other out. So you're just left with h minus 3. And then all of a sudden, it looks a little more simple again. Okay, and then for the right side, 6 times 4 is 24. Okay, h is not by itself yet. It has a minus 3. The inverse or opposite of minus is plus. So I'm going to add 3. But if I do it to one side, I have to do it to the other. So I can just bring down my h. My 3's cancel. And 24 plus 3 is 27. Okay, so let's look at number 10. We have p plus 7 over a negative 2 equals a negative 4. So I need to get that p by itself. And I don't see anything attached to it, but you can treat the numerator like it goes together and the denominator. Okay, so let's get rid of that denominator first. So if the left side is being divided by a negative 2 and I need that negative 2 to go away, that means I need to multiply that side by a negative 2. Okay, the number I want to go away is a negative 2, so I have to multiply by a negative 2. But if I do it to one side, I have to do it to the other. Okay, so your negative 2's cancel, and you're left with p plus 7. And then negative 4, negative 2 being multiplied. You can actually use your kissy face for multiplication as well. So negative 4, so that's a negative. So I'm going to scratch out one of my negatives. Negative 2, that's another negative. So I'm left with a positive. That means when I multiply two negatives, I'm left with a positive answer. Okay, and then 4 times 2 is 8. Okay, p is not by itself yet. I have a plus 7 in the way. So the inverse of a plus 7 is a minus 7. Bring down your p. Your 7's cancel. And 8 minus 7 is 1. Okay, so whenever I put my videos on YouTube, these are basically like if you miss something or you just want something fast or you just don't want the everything that we did in class. So these are meant to be quick. If this was too fast, please, like I said, go back and watch your class recording from September 1st or September 2nd. Have a wonderful day.